Welcome to DC Thursday. I'm Pete Soderling, the founder of Data Council and the Data Community Fund. And welcome back to our program where we interview a leader of a top open source data project or company. We've been running this program now for the last 6 months or so, and we've seen lots of great sharing and attendance from the community. So we're really happy that you're able to join us. Today, we're excited to have a really awesome guest and chat on active learning. So I'm pleased to welcome Dr. Jennifer Prendki, who's the founder of a new startup called Alectio. Jennifer has a distinguished past and history. She was previously the VP of machine learning at Figure 8. And before that, she was the chief data scientist at Atlassian. In addition, prior to that, she was the principal data scientist at Walmart's lab. So she's had lots of great industry experience. But before that, she was a postdoc researcher at Duke University in the field of neutrino physics. And she also received her PhD from Sorbonne in Paris in particle physics. So Jennifer, that is quite a list of achievements. I wanted to welcome you to the show.
Thank you, Pete. It's a pleasure to be there with you today. So yeah, I mean, you're right. It's a long road. I think that's been an interesting journey for me over the last few years.
Well, I have to say that you're one of the first people that I ever heard pitch machine learning active learning. And I know it's been a big passion of yours for the past bunch of years. Can you tell us, like, how did your research lead you into this field? What's the origin story of active learning for Jennifer?
Okay, so I mean, it's actually like there is like a long and a short story. So maybe I'll try to like cover a little bit like the origins, right? I mean, so as you stated earlier, I used to be in particle physics, and so back in the days when I was doing my PhD, so basically like around like 2000, like I did my PhD between 2006 2009, right? Back in those days, particle physics was a space where we would generate tons of data, and in fact, the volumes were very similar to what you see in the industry today. But you have to remember that these were the days of like pre-cloud technologies. I mean, AWS, I believe, was created in 2006, but it wasn't necessarily something very popular, specifically in academia. And people like me were basically looking for solutions to reduce the amount of data that they would train their models on, right? And so this is a time in my life where I really nourished the belief that big data is great. You need a lot of data if you want to find interesting insights, but those insights might be localized in some specific pieces of your data set, right? And so I wasn't using active learning back in the days, but I really had that impression that you can do great things with just a subset of the data, right? Then fast forward, I eventually, the way I landed in the industry was that, I mean, I was very passionate about physics. In fact, that was my dream to become a physicist, which I accomplished with my PhD. But unfortunately, that was the beginning of the recession, right? I mean, so there wasn't a lot of money to do fundamental research. And then this is when I realized that I could actually use my skills as an analyst, as somebody who's like very used to work with large data sets in machine learning, right? So I jumped into the industry, which wasn't uncommon back in the days for somebody with my profile. And the very first time when I started to realize I'm gonna have to be data smart, or like try to like go back to my original belief that you might not need as much data as you think, was when I was at Walmart, actually. So the story at Walmart was I was working at Walmart when the acquisition of Jet.com happened, and so there was like an internal reorg, and the funds started to be distributed differently, and so my team and my department suddenly had a much lower budget for data labeling, right? And so at the same time, the new CEO, who was the founder of Jet.com and had become the CEO of Walmart, also had this desire to increase the number of items to be sold on the e-com side of Walmart, right? And so very suddenly I was put in a weird situation where we had maybe a half or a third of the budget we originally had for data labeling, with somewhere around 10, 20 times more items to be sold, which means 10 to 20 times more data, right? And so I started doing research back in those days, like how am I going to make this work? And so this is where I first like become acquainted with machine learning, right? And so interestingly, like a lot of people who get started with active learning normally tend to start in academia, right? And so there is actually a lot of research in academia. I started active learning in an industrial setting where this was really meant to help with a specific problem associated to a return on investment of the project and then basically making the numbers work.
Well, that's fascinating. And I guess that was one of the things that drew me to the concept of active learning as well, is that it sort of turns the conventional wisdom surrounding training data on its head, where we've always thought for years, or maybe we've been sort of taught, or it's the message has been reinforced that the big tech companies have this massive unfair advantage because they have the largest training sets. But active learning fundamentally turns that notion on its head, doesn't it?
Yeah, absolutely. No, so I mean they're like so to go a little bit deeper into like how active learning works, right? I mean, so very simply put, like active learning is basically an answer to this, you know, like need that many people have had, that basically they cannot afford to annotate or label their entire data set, right? I mean, so that might be either because labeling is too expensive, it might be because labeling is too slow, or in some areas, for example, in healthcare or in legal tech, the people doing the annotation needs to be an expert, right? I mean, so in fact, oil companies tend to use like geophysicists to try to kind of like make a guesstimation of whether there's going to be oil in a specific area based on a certain observations they're going to make, right? And you might not have such experts available. In some cases, you want a surgeon to do the annotation, and so basically, like you have to pay a surgeon its typical salary to get this data annotated, which can be crazy expensive, right? And so essentially, like the active learning actually, like I usually like to say, like it's easy, like it's an easy to understand concept, but it's an incredibly hard concept or process to put into application, right? So for those who are not familiar with active learning, like actually, like the way, like what active learning is trying to do, so basically, like first and foremost, it's what you call a semi-supervised training process or paradigm. Right?
Okay.
So basically the idea, like semi-supervised by definition, is you work with some labeled data and some unlabeled data, right? Now, where this is interesting is, like, as you stated, like basically you try to like sort of reduce like the amount of data you're going to work with. I would still say a large company or a large data set is an advantage, because the larger the data set, the larger you have to pick from, and the pickier you can get, right? The more useful the useful data is going to be in this data set, right? Now, the advantage of active learning, like, was originally, so I mean the way it works is it's actually a succession of steps that help you explore the data and assess its usability as you keep going, right? I mean, so a lot of people tend to like mix with online learning or other concepts. So basically, like active learning is actually like the definition is pretty simple. It's like the succession of like a selection step, which is about like selecting a subset of the data. So how you select is the big question, of course. Then you annotate this data just the same way you would do for a regular labeling process, right? Except it's just a part of the data. You train your model. So you're going to have like a model, except that this model is going to be trained on a small fraction of this data. And then this is like the trick of active learning, is that you run predictions and inference with this model you just got on the unlabeled part of the data. So you sort of like generate synthetic labels. And based on what's happening during the inference step, you go back to the next, so basically you call that a loop, you go back to the next selection step and you say, like, now I believe, based on what I'm observing at this point, that these are the records I should be adding, right? I mean, so it's a selection of like select, label, train, infer, and so forth and so on, right?
But you're doing this on a subset of the training data each time.
So you keep adding more and more. So it's an incremental discovery of usefulness of the data based on what you observe, right? I mean, so this, of course, is reminiscent of, you know, like the reason why it's called active learning is like it's the same like active learning way of teaching to children, right? Which is observing the reaction to a child or how good a child is specifically doing and going back in the process, right? Now the trick here is that because your data, the data you're picking from, is not annotated just yet, you cannot do that by just saying, okay, my model is failing at understanding cats, right? Or at understanding pedestrians, because you don't know what the pedestrians are, right? Besides, you might have a situation where the model fails to understand cats, but like the problem is not necessarily you need more cats. You might need more anti-cats or the other type of objects that cause the model to believe, you know, like this is a cat when it's not, right? I mean, so a lot of people believe that active learning is just simply trying to like assess the weaknesses of the model based on the test step. Which is not the case in here, because like in the case where you identify this on the test set, you have annotated data that you can make a decision of, right? So here what you need to do, because you are running this inference on the unannotated data set, you can say this is a bad prediction because you don't know, right? You don't have the labels, right? What you can do is basically try to guess whether, you could almost see this as being like trying to put like a sort of like a lie detector system around the model and try to see whether the model is seriously believing something or if the model just makes something up, right? So usually what I like to say is like models cannot tell you they don't know, right? I mean, so essentially like they make a prediction no matter what. What we have to do is basically identify whether they're certain or not, right? I mean, so, and for that reason, like one of the main ways of doing active learning that everybody considers to be the vanilla use case is basically to look at the uncertainty of the prediction through something like the confidence level, right? I mean, so in this case, like the selection step is done by saying that I'm just gonna focus on the data that was predicted with the lowest confidence, because this is what the model is going to find the most interesting, right? And so this is where problems begin, right? I mean, so the process on its own is actually very simple, very easy to understand why you would do this, because this is the way we even teach children, right?
Got it.
The way you select is actually pretty complicated.
So that's the trick. So the trick is how you do the selection. Yeah. So before we get into that, I want to go back a step to your Walmart Labs story. So did you implement this in Walmart Labs, and was it successful?
It was an early.
What's the end of the story?
No. So there was a very early version, which was like, so I mean, it's a little bit different from the way we do this now. But yes, we were pretty successful, like smartly, like trying to prioritize some of the most interesting records. So yeah, I mean,
and this was around what year? 2015 or so?
I think it was 2015, 2016 and 2017. Yeah.
Okay, got it. And were there other companies that you were aware of that were using active learning in production at the time?
It was interesting back then, because I started, like, this is the point where I started feeling like somebody has to make this a common product or a common, like, not necessarily, and back then I wasn't thinking about starting my own company, right? But I started talking to people. It's like, do you also have problems with data labeling? Now you have to put things into context that back then, like Walmart, like is, you know, like the largest organization, right? I mean, obviously they have a ton of data, which is typically larger than most companies. I did talk back then with a few people at Lyft and Uber, or like in the few following years, like 2017, 2018, etc. People were barely starting to use this. And so I think, like, just like myself, like we all found out exactly what I said, that it's a very elegant, promising solution, but there is a ton more research that needs to be done to actually like make this work in real, in a sense. In fact, I will go one step further. Like, research is one piece, but the operational side of active learning is actually pretty complicated as well, as you can imagine, because we're already struggling like to operationalize like regular supervised learning processes in production. You can imagine how complicated it can become when you do something like this.
Right. Well, you're obviously very passionate about this space, and ever since I've known you, you have been. So this was part of the impetus that inspired you to start Alectio. So you decided to start a whole company around the challenges surrounding active learning. So tell me, what does Alectio do then?
No, okay. So basically, to finish the story, right? I mean, so basically, when I was at Walmart, as I said, it's like it was really starting to dawn on me that, you know, like companies are gonna have to use this. We're probably first or early because of the huge volume of data that Walmart had, right? But like it was very clear to me that the market would go in this direction, right? And it wasn't my ambition to start a company. So I mean, back in those days, as you know, I started like evangelizing like the concept of active learning through blog posts, like conferences and so forth and so on. My job after Walmart, so I went to Atlassian. I basically got the incredible opportunity to start the entire like machine learning function from scratch over there. And that wasn't necessarily my first priority because we were starting to like build data pipelines and do the basics you need to get started with machine learning, right? But it was on the back of my mind constantly. So I would almost say like, you know, like eventually it's like the call to do something about this became really strong. And that's when like I completely like opportunistically like figure eight, right? I mean, so the company that used to be known as Crowdflower was for VP of machine learning. So I was like, haha, maybe that's what we should do, right? Now, what's one of the reasons why I believe like active learning is still today like not necessarily very popular is like normally you would expect that concept to be like broadcasted and publicized by labeling companies, right? The problem is obviously the economics because a labeling company makes money based on the volume of data that their customers are going to annotate, right? I mean, so there's a conflict of interest in other terms, right? So this is like, I as much as I felt very passionate about this at Figure Eight, like there wasn't really like a clear opportunity, a clear path for the team to like build a product in direction, right? And so eventually as like I mean, I think we're really reaching the point where, I mean, I don't know if you heard this, you probably heard it from me at some point, but even if every single person on the planet stopped everything they're doing to annotate data, there wouldn't be enough people to annotate all of the data that we generate, right? And even I believe even for a use case like autonomous driving, because there's just so much data, right? I mean, so if you keep in mind that you know, like things are gonna keep getting worse, we're gonna have like a timefolds more data coming from those same companies in the future. Something needs to be done about it, right? I mean, so
but you found that the labeling companies were not as excited about this approach because they weren't willing to change their business model. Is that essentially what it boiled down to?
That's a nice, like yeah, I mean, that's the short answer to this, right? Now, what is interesting as well is basically like so a lot of like, I mean, thankfully, right, there is also another, like, I think people starting to realize that they can't even service their customers, right? I mean, so I think like there is a little bit of pushback from the market because even if you want to keep like your money stream coming in, right? I mean, at some point, if it, like, I think labeling companies see that sometimes they have like a time falls, like more data that they can even afford to annotate, right? In fact, a lot of customers of labeling companies complain about the lag, right? I mean, so a lot of
they all have a backlog, right?
Exactly.
Yeah.
So basically, like labeling companies today are starting to realize that you can use machine learning to make things better. And the typical machine learning, labeling company would have a tendency to build tools to scale up the process of data labeling, right? I mean, and basically, like you have more and more companies like living on the principle that you should do human in the loop data labeling, which essentially means like you build a process to separate the easy use cases or the easy records. You route that to an automated labeling process. You let the humans take care of the corner cases, right? I mean, using the Pareto rule where, you know, like there's like 20% of the data that's maybe difficult to annotate. You can do it in another way where you annotate everything with a machine and you let humans just like review it quickly, right? I mean, so it's not the best idea in the world because of course you still need humans to revise everything, but it's better than nothing, right? And there is a huge effort on the market in this direction, right? And so in fact, like this is also something that we prone because in order to be successful with active learning, you need to be able to trust your labels, right? This is a pretty important point if you want to work properly. Right? Where I see like, and at Alectio, like I really saw like the right way of solving the problem, not as increasing or scaling up the amount of data to be labeled or the labeling process, but scaling down the quantity of data to be used in a model. Right? Why? Because if you reduce the amount of data, you do solve the data labeling problem or like the big data labeling problem, even the crisis, I would say, right? You're also solving other problems such as first like explainability of the data, which part of your data is useful, why is it useful. You can actually, we do use active learning also to sort of diagnose problems you can see in your model. And generally speaking, you also have a hope of reducing compute, right? I mean, all the amount of training.
Yeah.
So that's sort of tricky because active learning in nature causes you to retrain on a regular basis, right? I mean, so if you do it without like the dumb way, right? I mean, if you want to put it that way, you would have to like first with like, let's say a subset of the data, like let's say 10% of your data, you select the additional 10%, you're gonna retrain on this 20%, right? I mean, so the original 10% you had plus the 10% you got. So if you do the math, like you're gonna train on 10%, 20%, 30%, 40%.
Right.
You're already over, like you're reaching the same amount of compute, right? Knowing that for deep learning, for instance, the relationship is linear between the amount of data and the amount of compute, right? So so that's a problem, right? I mean, so that's also another thing we're trying to identify and develop ways to do active learning in like we call that compute saving active learning.
Got it.
Essentially,
So
retraining on the same batches.
got it. So there are definitely some challenges with active learning that we can discuss. But basically, at a high level, what you're saying is that as an industry, we're awash in data. We've been taught that more data is always better. But it turns out that there's significant bottlenecks that pop up because of the fact that we're trying to use all this data. And one of the most obvious bottlenecks is we just can't label it all. So this whole notion of iteration over a machine learning workflow, you don't just build the model once. You have to build it and tweak it. You have to build it and train it and tweak it. You have to build it and retrain it and retweak it. So there's this whole iteration process that seems to be like stagnating because we don't have modern software development capacity, and we don't have this iterative notion of sort of like unblocking ourselves in some of the things that matter. And so because of the way specifically active learning handles this approach and really handles the need for, it sort of enables the need for less training data, it starts to remove a lot of these blocking issues in the machine learning workflow. Is that right? Yeah.
Absolutely. So since you're talking about life cycle, I'm going to add something more as well, which I think is actually pretty important about active learning. And this to me is like a really, like once you understand this, you understand like really where active learning can impact the industry in general, right? So, that's a story I think is also like sort of relevant of like my own story, right? But like, so when I took my first machine learning job, right? I mean, shortly after I finished my my postdoc, right? I joined a company where like similar to what you see today, like the head of engineering is like, we need to do something with AI, machine learning, and they didn't know what, right? And so this still happens today, right? And so I joined. I was like, okay, what kind of data do you guys have, right? And so, we don't have much. We don't like, you have to figure it out, right? And so it's like, I mean, and a lot of people starting their careers now in machine learning would like relate to that sensation, right? So anyways, so what I did is like, I didn't have a lot of experience setting up a data collection process. So I started looking into the code, what sort of like, there was an advertisement company. So basically like what sort of like click-through rate am I going to capture, where, how, etc. I worked with the engineering team. And then I had to sit there for like 3 months, right? I mean, doing something else. I started helping on like the engineering side a little bit, but it took time to build a historical training data set, right? And so once you had this data, and I was ecstatic, I was like, okay, great, now I can start building a model. I started doing some work on it. And then to my despair, it's like, I forgot to collect this thing. I should have collected that. This wasn't done the right way. We, like basically like we didn't collect like with sufficiently enough precision, like a specific number or so forth. Right? And I started seeing lots of problems in the data, right? At this point, it was too late, right? There was no going back and like, I'm gonna change my data collection process and start over, right? So you had back in those days to make your model work for the data, right? So it's like you had no other choice, right? I mean, so it's like if something was missing, you had to like find a proxy, like give up like certain dimensions, etc., right? And we were all trained with that impression that the flow is you collect data, you build a model, you deploy this model, and then you start over. That's what the life cycle is, right? Nowadays, so basically, like when you think about this, as we kept being better and big data started becoming faster, higher volume, and so forth and so on, that problem started to disappear, right? Which means that instead of having to wait for 3 months to get a training data set, you might have to just wait a couple of days or a couple of weeks, right? Depending on the process, obviously. Right? And which means that nowadays, you have the option of being picky and realize you make mistakes and redesign a more perfect and a more suitable data set, which means that you can now also tweak the data set to the model. And this, to me, this is partially what active learning does, right? I mean, so we need to jump back into like our beliefs that it doesn't need to be this way. You don't necessarily have to collect data first, freeze this data set and make the model work for it. If you realize you cannot make the model work, if you realize that the model would get better if you added something additional, you can go back. You can add more data, you can tweak your data collection process, you can add more features, right?
So it works both ways. And it sounds like what active learning allows you to do, if I'm not mistaken, is it allows you to understand the subset of your training data that's actually impacting your model. Because one of the dirty little secrets is that all of your training data does not impact your model equally. Is that right?
That's exactly right. And so this is something that people don't see just yet, because active learning, as I was explaining before, was originally built for people who have too much data, not enough labeling capabilities. They just want to find the subset. Now you have a tremendous advantage with this, that you can essentially use and build a feedback loop around this to say, like, wait a second, let me try to understand why this data was impactful to my training process.
Right.
In fact, you can also, and so these are the sort of things that we do a lot at Alectio, is basically to say that sometimes you will observe that the model prefers, whatever that means, like a specific subset of the data. It's going to pick that data first, and then eventually when it runs out of that type of data, right? I mean, so type of data might be like pictures with small pedestrians or small objects or large objects, or, you know, like a specific density or specific combination of objects or whatever, right? When you run out of this, the model suddenly like slows down its learning rate, right? I mean, and you're gonna see that it seems clear to me that you need more data of the same type, right? I mean, and so you can actually use basically what happened during the active learning process as a process to refine your data collection process, find the additional data that's necessary. In fact, we started doing that as well with synthetic data generation. So basically what you do is like you generate a lot. And so in this case, in the case of synthetic data, there is no labeling, right? Because the data comes like you already have full understanding of which data you annotated, right? Or sorry, you generated, right? I mean, so you're not even thinking about reducing the amount of labeling you're gonna have to do, right? What we do is just like try to get an understanding of what made the model comfortable at which point, to basically sort of analyze like this is the data you need to generate more of. And people are completely, like, I think the vast majority of people who are even aware of active learning see active learning as its main value proposition being reduction of data labeling cost, which is a very small fraction of what you can do.
So we've talked about what active learning is. We've talked about some of the benefits. Just so we have some comparison contrast, why do people confuse online learning with active learning? What are we missing there?
Well, I mean, I think, you know, like, I think the answer to that is pretty simple. Like, look, when I started back in the days, right, there was no like machine learning curriculum in universities, right? I mean, so in fact, like a lot of people who today have like 10 to 15 years of experience in machine learning and data science would be people who were like previously like applied scientists, etc., right? And so now we are lucky to have, like, in most universities there are machine learning courses, there are courses on you know, like on the web and so forth and so on. So I mean, it's easier for people to learn machine learning, but we're still early stage, right? And so a lot of these courses are still like the basics, right? And for me, like, one of the big missing pieces, like I mean, there isn't enough awareness even in academia of what active learning truly is, right? And so in fact, in many places, I've seen people actually believe that active learning is the concept of having to retrain a model with additional data, right?
Okay.
You see a lot of people actually see active learning as being like a process where you strategically pick data, which is what active learning is, except that in this case, they sort of do what I said earlier, like to state that since my model is struggling with cats, I'm going to add more cats, which is technically not active learning because you already annotated the data in the first place, right? I mean, so it's
well, I
just like
guess maybe,
awareness, right? I mean, so it's like, I mean, and I'm glad you're doing this podcast to try to address this today.
well, maybe it's a little confusing, and then you know this goes back to something that you and I have discussed over time. It's should active learning be capitalized? Is it you know capital A capital L learning, or is it just a collection of technologies?
Absolutely.
Because it doesn't seem like it's one technology, right? It seems like it's sort of refers more to the workflow process of several steps.
Paradigm, right? I mean, so it's like it's really it's not a model. I mean, something else I've seen is like, in fact, when we started Alectio, we would pitch like basically you should be using active learning. People would say like, I'm good, I already have a model, and so you had to educate them on like active learning can be used with any model. It's just like a wrapper, a process around your model, right? So it's like yeah.
So we talked about the easy standard way of active learning, which is select a subset of your data, train your model, watch the performance, and then sort of go back and figure out a new set of data or a new subset of data to select. You call that the normal method of active learning. What's a slightly more advanced version of that model?
Yeah. No, so even before, just as a transition for this, actually, right? And so you ask like why people like you know like are not aware of active learning. I'm gonna say like I see a lot of people too who are aware of active learning, tried active learning, and just gave up, right? And so the reason why, and this is another reason why like you see like a slow adoption cycle on the market right now, is that people use what I call like traditional active learning, right? I mean, so basically like I talk to a lot of people who say like, oh yeah, I know active learning, I've done it before. And so it's pretty much the same thing as to say I've done deep learning before. But as you know, you can do deep learning, you can use CNNs, LSTMs, you have to define the number of layers and so forth and so on. And so I often see a similarity where back in the early days of deep learning, people would basically like they would get excited because they read papers, and then they would apply that to their data set, and then they would say like okay, it's not working for me, I give up, I go back to my old-fashioned traditional machine learning models, right? I mean, random forest or whatever. And the reason for that was like not eventually, as you know, today people are using deep learning all the time, right? Because they realized that there is a lot of work that needs to go into tuning the model, identifying, like there is actually a lot of heuristic knowledge, right? I mean, you have like you need to get used to it to get some like intuition around like what's the best number of layers in the case of deep learning and so forth and so on, right? I mean, so it's like people are still at this stage where because they don't understand this piece, right? I mean, they just like, they try, it fails because usually it does, like the traditional active learning is kind of like you have to be extremely lucky for this to work the right way without having to do any sort of tuning, right? And they just give up, right? So to answer your question about like what I mean by traditional, right? I mean, so I'm gonna go back to my flow with like select, label, annotate, train, and infer, and then you go back, right? The critical piece here, and the question everybody's gonna ask, of course, is like, what is the select piece? How do I select? What feature do I select, right? So normally what you do with active learning is basically like, it's almost like you're trying to listen to the model. Usually I say it's like measuring the model's vitals, right? I mean, so when a machine learning model learns, something is going to happen to it, right? I mean, you're going to have variations in the weights and the biases of the model. There's going to be like something with like a specific value for the activation function. You're going to have like some, you know, like uncertainties you can measure during the inference process. There are many ways to doing this, right? I mean, you have like cases where you can like sort of like distort the model a little bit to measure like agreement across like an ensemble of similar models and so forth and so on, right? And if you measure those vitals, then basically like you can use those vitals to make your selection as smart as possible, right?
Okay.
original way, or the easiest way to do active learning, is essentially to say you're gonna pick the X records that were predicted during the inference step with the least confidence, right? And so this is interesting because like you're really like, there are a couple of problems with that, right? I mean, so it's like first and foremost, like you have to believe that confidence is a proxy for interestingness, right? That means, right? And that might or might not be the case, right? Imagine now the case where you are training a sentiment analysis model on English tweets, right? And for whatever reason, you have some foreign language in your data set, right? Let's say 3% of my tweets are German because I didn't do it properly, right? I mean, guess what's going to happen if I do inference on those German tweets, right? I'm going to have a low confidence, right? Do I want to use these? No, right? Because they're exactly the opposite of what you're training. Right. So that goes, and this is another important point, in the fact that any training data set is made of useful, useless, and harmful data. The traditional learning is focused on trying to remove the useless data, making the assumption you don't have something called harmful data.
That's right? Overtly harmful.
So do this, in this case, what you're gonna do is select those German tweets first, and you actually were building a worse data set over time as opposed to building a better one, right? So this is exactly why you cannot just rely on one feature, just like our meta feature, like in the space of like the happenings of the model, right? So so basically, like usually the way I see this is like the traditional active learning is a rules-based algorithm. You're just gonna predetermine this rule as being like, I'm gonna pick the 500 additional records with the least confidence. And you have no reason for that.
Problem with that.
Like, I mean, so you can be street smart, change things a little bit. And so that's another reason why people don't really necessarily like want to spend time with active learning, because you have to try, right? I mean, so basically, like if you don't have a better framework, you're going to have to try different querying strategies. So query strategy is the technical term for this selection process, right?
Yeah.
And it takes time, right? I mean, so at some point you might realize, you know, like between having to pay an additional like $10,000 for data labeling or having to spend 3 months trying to find the right querying strategy, my choice is made, right? I mean, and yeah. So I mean, basically what I really believe needs to be done is to believe and to accept the fact that we're still at an early stage where we need to get better. We are using a rule at this point. Usually most people, 95% of people doing active learning use the same rule. It's very unlikely to work, right? And this step needs to be machine learning driven, right? And it can be machine learning driven because you can collect data and information associated to the psychology of the model, right?
So where do you see active learning at in its adoption curve? Like as an industry, will we be able to sort of educate and sort of solve some of these challenges and make active learning more approachable? Like what's the secret to doing that, do you think?
There's no doubt on my mind, because like we're reaching the point, and this is interesting for us as a
company. Because the potential is amazing. The potential is amazing, right? But it's amazing that to me that more people don't sort of embrace this and at least give it a try.
It's the answer is like, it's complicated, but like this. So when I started the company, like people were really like almost, you know, like in disbelief that this can be done, because we still live in an age where the big data industry wants to promote the necessity of using as much data as possible, right? And so when I started Alectio, like when I was trying to pitch, like basically like you can actually use less data, right? And so actually we do things where we do something called meta active learning, which is a one-shot way of like trying to predict the useful data, which is basically like building a model on top of the active learning process, right? And when I would try to promote to people, like this is what you can use, right? I mean, and you could actually train the same model with just a fraction of the data. In fact, you could build a better model because you can also get rid of the harmful data that causes problems to the model. Like people are like, but my teacher, my boss, my friends all say I need more data. I don't believe you, right? So nowadays things are quite different. People still don't quite grasp how this works or how this can be done properly, right? But they need it, right? I mean, so oftentimes what we see a lot is like, look, I have no idea, like I'm worried that this is gonna bias my process. I don't see how I can get a better a better accuracy with less variance. So it is also important to say that basically you can keep the same variance while reducing the size of the data set if you keep the right records, right? And basically, like at this point, it's more like I need this to work for my machine learning initiative to function, right? I mean, so one of the core mission to us, and this is very, very dear to my heart, it's basically like, I believe we are in the schema where you have a lots of amazing machine learning companies out there that just cannot get a return on investment because the money they invest mostly goes to hardware, compute, cloud technologies, AWS credits, right? Data labeling, right? And the money should go to research, right? I mean, or at least a decent part of the money should go to research, right? I mean, so I think this is a necessary step for like getting the basically like the market back on track and like ensure. And this is really important to me. Like it's almost like necessary to ensure that we don't fall in the next AI winter. This is like, you know, like, and you see, like, I don't know if you know the numbers, but as per like recent reports from like analysts on the machine learning market, 90% of companies claim that they tried or they have tried something with machine learning. Out of those, only 40% say that they see any difference at all in terms of what it brings to their business, right? So it's like, for me, it's like a big red flag that we as an industry need to prove that, of course, like I think we reached the point where everybody knows that we can do amazing things with machine learning. But if you don't do that cheaply, efficiently enough, the industry and the business people running those companies are going to give up on us. Right?
Yeah, that's fascinating. Those are really great thoughts, and I can see how removing this high place of, you know, lots of training data could definitely help smooth that over. I'm curious to hear from you, like, are there some classic use cases or industries where active learning makes sense? I know we've talked, I think, in the past about visual data and other things, but talk to me a little bit about what you've learned over the past couple of years in terms of which industries and use cases it makes most sense for.
Yeah, no, so it's like, you know, like, so first and foremost, I will say this, right? I mean, so active learning is not magic, right? I mean, so if you have cases where you actually don't have enough data, right? I mean, so basically, like when you run an active learning process, like the key graph you want to monitor is called the learning curve, right? I mean, so a learning curve is basically like this graph of like a performance of the model, which might be accuracy or something else, right? Versus the amount of data. And typically what you see is like something that plateaus, right? So basically like so if you, like, the goal of active learning in this case is to prioritize the most useful data as soon as possible so that this curve is as step-like as possible, right? And there are, like, if you randomly add more data, you're more likely to see something that's eventually going to plateau as well, right? Because you have a diminishing return on like additional data at some point, right? But it's gonna look more like a regular, like, linear curve, right? You have cases where you clearly see that the model is data starved, right? I mean, so in this case, you use active learning to basically say, okay, sorry, my friends, like, you clearly need to collect more data, right? You have cases where you still haven't enough data to reach the point where a significant part of your training set is redundant or irrelevant, right? When you think about, like, so going back to my concept of like useful, useless, and harmful data, the useless data is typically useless for two reasons, right? I mean, number one, like, the data is irrelevant, right? So it's like you're training a facial recognition algorithm and there is no one on picture, right? And you have the case where the data is redundant, or the information in the data is redundant. It doesn't mean you have twice the same picture or the same record. It means that the information that's contained in there is something that's basic to the model. So basically, like, you have cases where you still don't reach that, like, you might be in a situation where all of the data is relevant and you still don't have sufficiently enough information to call that information redundant with something else, right? So those cases, like, for example, there are areas where they are still struggling to get data, right? I mean, and so basically, like, I would say, like, there are like slow data collection processes. You could imagine like areas like if you are a healthcare company working on like a very specific like type of cancer, something like this, right? I mean, so you're gonna already struggle with the dimensionality of the data that you're working with, right? They are not necessarily gonna be particularly prone to using active learning. At the same time, these are typically areas where annotation or annotating the data is very expensive, right? I mean, so you have to, like usually what you observe is like, usually it's not useful until it becomes critical, right? I mean, because you suddenly fall in the bucket where any record that, like, think of like a healthcare, for example, annotating a record for a patient might be you have to run new tests with the patient. You need to do, draw some blood from that patient, right? Which is going to be expensive and slow, right?
So does it make sense to try active learning in those high dimensionality use cases?
Yeah, you could, right? I mean, so basically, like, I mean, I would say I almost see active learning as a way to like diagnose the richness of information, right, in your data set, right? I mean, and so totally something I would do, right? Now, the examples like on the other end of the spectrum where active learning is typically very interesting is basically like autonomous driving, right? I mean, so autonomous driving, you can imagine that you have similar situations over and over again, right? I mean, at some point, very quickly, the interesting data is going to be the corner case where there is an accident in front of the car, right? Which doesn't happen on a regular basis, right? And so in this case, like there is a lot of redundancy of information.
Because overall, you have lots of data.
Yeah, of course.
Yeah.
So basically, like the problem though is basically like you have to go back to, and this is one of the problems we're trying to solve. Like when I said like compute saving active learning, right? One of the problems we still have with like most like active learning cases is like it's really a trade-off between the time you're gonna spend setting it up, running an incremental training process, which means like typically it can be more compute if the compression is not dramatic enough, right? And labeling, right? So autonomous driving is tricky as well because labeling is fairly cheap or can be fairly cheap, right? Because this is not the corner case where you need like a specialist, somebody who's a surgeon or a lawyer to do the annotation, right? I mean, so there's been a race to the bottom in terms of the pricing for data labeling, right? I mean, so those companies have to ask themselves, right? How much do I care about like go-to-market time, right? And money, right? And so and it's usually not an easy answer to give, right? I mean, so basically, like if you're gonna save like a $15,000 in data labeling by using active learning, but you're gonna spend an additional $10,000 for compute, and you're gonna spend a month on it. Do you or do you not want to do this, right? And so active learning is actually pretty tricky because it's really hard to predict ahead of time which sort of compression you can hope to get, right? And so on. So this is something that unfortunately we don't have an answer to just yet, but we're hoping to get an answer in the next few months, right? But like it's all about the economics. But I would say, like as we stated earlier, there is a benefit into like trying to understand usability, usefulness of the data. In fact, I would see some cases where you want to use active learning. Like you might figure out from active learning, wait, even though I don't have a lot of data, my learning curve is flat, which means I'm not collecting the right data. I need to change my sensors. I need to drive in different locations and so forth and so on. Right? So I don't see any harm in like at least trying active learning for the purpose of diagnosing the process, right? Even if you don't necessarily want to use this in production right away.
That's fascinating. So what advice would you give for listeners who want to get started with active learning? Like, what's the best, most approachable way to get started?
No,
sorry.
I want everybody to try, obviously. Right?
Yeah.
No, but like first thing I would say is like I want people to realize that there is no such thing as like active learning, right? I mean, when somebody says like I tried active learning, it's not working for me, it's like chances are you're not thinking about the problem hard enough. Active learning is not just about least confidence, right? So you have to be patient. You have to gain an understanding of like the different like ways you have to do this. We're very lucky that like in 2020, there's never been as many papers published on active learning. So we're way beyond the vanilla use cases at this point. And so we're not the only people doing research on this. The other thing, so since you mentioned open source, right? I mean, so obviously we are a platform that typically services like enterprise and startups to try to help them like save money, do things more efficiently, identify their problems. In fact, people use us for a variety of different reasons. But we do have a community version, which basically like the difference with the community version and the rest is like the community version, you still have to do a little bit of work, but we have like a pre-established list of querying strategies. We have examples of how this works on different use cases. So basically like if you can start using the platform to discover that, for example, there are some querying strategies which are more advisable for an object detection problem than for something else, right? I mean, so I'm not gonna tell you what because I want people to go and check for themselves, right? But I mean, so yeah, I mean, like we're trying to provide tools for like basically driving awareness for active learning. So it's like I encourage everybody to go try this out and reach out to us because you can use the platform, at least the community version of the platform, even without paying. Right?
That's great. We will we'll put a link to the community platform in the show notes so that folks can check that out. So thanks for chatting, Jennifer. I always learn so much about you from you whenever we chat, especially on the deeper technical topics. I did want to just shift gears before we wrap up and ask you more of a business building, company building question. What has it been like to start Alectio as a single founder? What are the biggest challenges that you faced over the last few years? Because I know with any startup, I've started several, and all of us have challenges and ups and downs. But I'm curious about what you've learned about yourself and how you might frame any advice for folks in the community who might want to start a company.
Oh, sounds good. No, so I mean, what's interesting about my journey is like I never want, like I call myself the reluctant entrepreneur, like or the accidental entrepreneur. It's like really like I never meant for this to happen. I just got really mad at some point that nobody was working on this, and I saw such a huge opportunity and such a huge need on the market, right? I mean, so it's like I mean, I would say like one of the strength I had is like I didn't start a business for the purpose of starting a business. I started a business for the sake of solving a problem, which I knew from my figure 8 days to be a problem for many companies, right? I mean, talking about the piece about like being a solo entrepreneur, right? I mean, so I mean, it was, I mean, same thing, was an accident, right? I mean, it's like basically like I did not start a company saying like, I'm going to prove to the world that I can start a company on my own, right? It was more like basically like I am on a mission and I didn't find anybody else who was like really passionate about this mission at the same point in time, right? So it was obviously a challenge for, you know, like getting people to like back us up, trust me, specifically being like a category builder, right? I mean, so basically like even like pitching to investors was always a challenge. That basically like why, I mean, I got that question a lot, like if this is such a promising technology, why is nobody else doing it just yet? I mean, my answer is like somebody has to be the first, right? I mean, so maybe that's me in this case, right? But yeah, I mean, so I mean, I would say the advantage I saw as a solo entrepreneur is basically like the ability of like align all the strategies, right? I mean, because one of the problems, like I don't know if you're aware of that, but like one of the big reasons why people tend to fail early stage with their companies is that there is a disagreement in the direction of the company between the founders. So at least I did not have that problem to deal with, and so I think we've been like pretty efficient like building and figuring out product market fit early stage, because I was able to align marketing with product, with engineering, with, you know, like make the right strategic hires at the right time without having to argue with somebody else.
Yeah, well, starting a company is definitely challenging, and sometimes it's easier with someone. Maybe you're right. Sometimes it could be easier without that co-founder to fight with. Yeah. Well, this has been a great chat, Jennifer. I want to thank you for joining us, and really appreciate you being here and sharing all of your wisdom with the community. So best of luck with Alectio.
Thank you.
So I just wanted to make a couple mentions to the community before we sign off. Please don't forget to leave us some comments on today's episode. There's a survey in the sidebar that you can check out. We love it when you sound off and let us know what you like or don't like about the show. Also, I wanted to mention that Data Council is doing a 2021 Open Source Data Tools Community Survey. We have one more week left where you can submit your responses on your top 3 favorite open source data tools. We've gotten literally hundreds and hundreds of responses from the community so far. So please make sure to check that out. Take 20 seconds. It's the shortest survey I have ever seen in my life. So please fill that out, and then don't forget to share it with your friends and your community and your coworkers. We'd really appreciate that. And finally, next week, February 25th, I'll be having a chat on starting a data company with Patrick Thompson from Iteratively. So don't forget to subscribe, hit the bell button so that you get the notifications, and we'll look forward to seeing you next time.